Welcome to this lecture on the time value of money. I want to just briefly introduce what we'll be talking about during this lecture. We'll start with introducing the time value of money concept. Then I'll proceed to the future and present values, single and multiple payments, how you calculate those through the time value of money, working with annuities, perpetuities, and then I'll wrap up with some big picture takeaways and just some final thoughts. So with that, let's get started in the time value of money lecture. So money has a time value component to it. Right? We know this intuitively because things like inflation and interest rate change the value of money over time. They erode the value or allow us to earn money on time. So our goal in this lecture is to understand this concept, these concepts more analytically. And we're going to develop tools and concepts related to the time value of money to help us quantify what this time value really is. Right? So more importantly, the time value of money concept is used throughout the field of corporate finance. It's a bedrock concept, and it's going to come up over and over again. So let me give you an example of what the TVM is. And let's take a look at this thing called future value. We have $100 today. What is that worth next year? Well, if we have an interest rate, let's say it's 5%, we can calculate with simple interest 100 times 1.05. That's $105 next year. Another example, $500. Let's say we have an interest rate of 8%. Again, we do the math, and this is a simple interest example. $500 today becomes $540 next year, assuming an 8% interest rate. All right, so that's the future value. So now let's talk about going backwards, the present value. So we know, let's say next year we're going to be receiving $1,000. What would that be worth today? Let's say we have an interest rate of 8%. We know that the amount today, the question mark, times 1.08 equals $1,000. So let's just rearrange this. 1,000 divided by 1.08 equals $926. So $1,000 next year is equal to $926 today, given this interest rate of 8%. One more example of the present value. We have $2,500 next year. What is this value today? So an interest rate, we need an interest rate. Let's just assume we're given an interest rate of 15%. Some amount today times 1.15 is equal to $2,500. Divide that out, and we can see that today $2,500 next year is worth $2,173 today, given an interest rate of 15%. So let's just summarize. These are more mechanics, but and I'll explain the big concept also here. So today we have we can go from the present to the future. That's called a future value calculation. And this equation over here on the right side shows us how we get from the present to the future. It's just a simple interest rate formula. We stick our money in the bank, we wait a year, and when we take it out, it's worth the original amount plus the interest amount. And that's the future value. Oftentimes, we actually are given some future amount. We're told in a year you'll be receiving some amount. And we want to know, well, what is that worth today? And it's the same equation from the future value. It's just rearranged. Instead of multiplying, we divide the future value by 1 plus the interest rate. So just a note of language here. Sometimes, because we're going from the future back to the present, it's referred to as discounting. We are discounting from the future to the present. And you'll also hear, instead of an interest rate, it will be called the discount value or the discount rate. So those are terms that you'll be hearing in finance in general when we calculate these present value calculations. And here they are side by side. So just now that we've got this up here visually, conceptually what we're saying is, given an appropriate interest rate or discount rate, we can actually make an equivalency between the present value and the future value. So in the previous slide, where I believe it was $926 today was the same as $1,000 in the future, we're really saying, given the appropriate interest rate, those two things are identical. So we would be equally happy with the $926 today versus the $1,000 in the future. All right, so now these were for single payments just 1 year apart. So let's extend this a little, and now let's look at single payments over multiple years, spread out over multiple years. So what do I mean by this? So let's say we have our $100, and this is in year 0. It's today. And I want to know, how much is this worth in 3 years? So the previous examples would have been this 1 year. And I want to say in this example now, let's go out 3 years. So to calculate this, so imagine we're sticking this in a bank, so we need an interest rate. Let's just say that's 7%. And we want to know, how much is this worth after 3 years? So this is just compounding, and we'll do it annually. So here's the math. It's $100 times, well, let's do it 1 year at a time. So 1 times 1.07. Right, that's just to get us to the first year, and that's $107, right? Nothing special there. Now we're going to leave the money in the bank in this scenario. So we earn another 7%, and that's $114, and then we do it again, and we end up with $122. So $100 today is equivalent to $122 in 3 years, given this interest rate of 7%. We are indifferent to receiving $100 today or $122 in 3 years, given this interest rate. And obviously that means we know we're going to get the money, and there's no risks of all that. That somehow all that's incorporated into the interest rate. So that's an example of a single payment that's over multiple years. So now let's just summarize this. This is essentially all we're doing algebraically is $100 times 1.07 to the third, which is 122, and we can generalize this. So it's really just the present value, the $100, times 1 plus the interest rate, I, raised to the nth, equals the future value. Right? So that will tell us for any single payment spread out over really any number of years. It could be 10 years, it could be 100 years. So we can use this formula to calculate it out. Now let's go backwards and just see what it looks like if we take the present value of a future amount over multiple years. So we have, I'm telling you now in this example, in year 3, we're going to be receiving $2,000. So what is that worth today? All right, well, you can imagine that we just have to go backwards. Instead of multiplying, we need to be dividing. Now, of course, we need an interest rate, a discount rate also, you'll hear. So in this case, it's 12%, and I'm just giving you that. So we start with $2,000 divided by 1.12, 1786. We keep dividing by 1.02 until we get to year 0, and that is worth $1,424. So $2,000 3 years out is equal to $1,424 today, given this rate of 12%. So what this is saying is we're really indifferent between receiving $1,424 today and $2,000 in 3 years. just to summarize this one, algebraically, it's the present value is equal to $2,000 divided by 1.12 to the third, and we can generalize it. Present value is equal to the future value divided by 1 plus I to the nth, right? We can do it for 10 years, for 50 years, any number of periods. It's the exact same methodology. So just to summarize this, the main equation is this present value times 1 plus I to the n equals the future value. And we can do it going forwards, or we can rearrange this same equation and divide by 1 plus I to the n to go backwards, right? And here they are side by side.